All right. So good morning, everybody.
So I emailed
Welcome
that to you.
Oop. All right. Good morning, everybody. Welcome to this week's NCDOT presentation in conjunction with NCDOT. We're pretty much doing what we call the OpenX Rollout Week. OpenX refers to all of the different Bentley Connect Edition brands. NCDOT. We're proud to partner with the Department of Transportation to bring you these different unit updates. This morning's session will be on hydraulics, erosion control, and utilities. So we have a lot to cover. We're very thankful for Bill, Jeremy, and John to join us and to give this presentation. Just a few housekeeping details. Webinar presentation. This is a webinar presentation, so all attendees will be muted during the presentation. At any time during the webinar, you can submit questions into our chat box to allow me to kind of field those questions at the end. And then we'll also at the end, we'll also open it up for anyone that wants to unmute and ask questions as well. Since we are doing 3 different subjects, we're going to ask that everybody hold their questions till the end if you want to actually ask them. But feel free to put those in the chat box throughout the presentation. We're recording the webinar, so we'll share the link after the event. It's also on our website, so those will be posted throughout the week, so you can go back and watch those in the past. We're offering PDH credits for anyone that is registered and that has attended the meeting, and then we'll send those PDH credits out after. If you did not attend the live meeting and want to watch it afterwards, that's fine, but you will not get PDH credits for that. If you have any problems with your screen freezing, we've had someone in the past couple of days have that issue. Just jump out of the meeting and jump back in. We found that fixes the problem. We're not sure what's happening, but that seems to be a fix. And feel free to reach out to us if you're still having problems with that. That's it for this morning. I guess I will introduce Bill. Elam is going to be presenting with the hydraulic unit for erosion control. Jeremy Goodwin's going to be presenting, and John Lowry will be presenting for the utilities. So, Bill, I think you're first up on the deck.
Yes, sir. Good morning, everybody. My name is Bill Elam. I think most people know me. I worked in the hydraulics unit for almost 30 years, spending 20 years of that working with geopack drainage. And now I'm working with AECOM, but I got brought back to the hydraulics unit to help with the ORD transition when Mike Kelly retired. And I'm going to go off the rails right now just to thank all the people that have helped us, which is Charles Smith built a lot of this in the beginning with Mike Kelly. Mike, who everybody probably knows too, built all the 3D cells. Michelle Berry has been working to try to she's our super user. And then Ernie Hahn has helped a lot. He's worked on the cell library since Mike's left, and he's helping keep me straight. And Ryan Majub is a new person that's helping us. And there were people that worked on Kimley Horn, several other firms that worked, I think back in like 2019, maybe or before COVID struck, where they were starting to run some test projects to try to see what was broken and sending stuff to Bentley. So without all those people, we wouldn't be where we're at, even though we're probably still not as far as we would like to be. And probably won't be until we're really going live and seeing where all the bugs are. But now back to your featured presentation, and I will try to not talk too fast or Ernie will hit me on the back of the head. So geopack drainage, ORD is a major shift from geopack drainage. Drainage and utilities is one of the workflows that was created in ORD. It's the replacement for geopack drainage, and it also includes utilities, obviously, which John will cover later. So drainage part of the ORD drainage and utilities is from OpenFlow StormCAD, and that's the design engine. OpenFlows also provides most of us FlowMaster and PondPack, and used to be Haystead, if you remember that. If you're familiar with StormCAD or CivilStorm, then you've already got a head start on the rest of us. for hydraulic designers like me, geopack drainage is gone, and most of the roadway tools have changed the way they look or where they're at. So we have a big learning curve. Um, we've been using the same software for over 20 years, so we know the pros and the cons, and we know the workarounds for geopack drainage, and that's our comfort level. But it's time to move forward. Uh, I think one of the biggest challenges that I have right now is that when we started with geopack drainage, we had years to learn how to do geopack drainage. I mean, I used it for years before anybody else, really most people outside of me used it. So I knew how to fix it. I knew how to help people troubleshoot. Once everybody got used to it, that's when we started figuring out how to get the drainage summary sheet incorporated in. Now we feel like we've got all these tools. We need to start at that point, and we're going to do the best we can. Um, but it seems like a steeper ladder to climb. Um, so where are we at? We've made the first pass at the workspaces. We're probably getting ready to post them. Uh, we know there's going to be problems with them, and as y'all find those problems, you need to let us know. We're trying to figure out what's changed in 1010. We have a hydraulics manual coming in the works. The first draft has been completed. It's been reviewed and returned to the firm. The manual we hope to post online August 1st. I'll go off script here again to basically say that we are going to try to work to create a web page, or we're either going to have a web page that we do in conjunction with CAD services, or we'll have one on our website, the hydraulics website, that will have links back to it from the CAD services, whichever way they want to do it or whatever works best, to try to have some of these manuals and some workflows and stuff out there that we've got. Now back to the process. So let's see. Our goal is to be able to use ORD drainage for design and not as a validation tool. In talking to some other states, they're using it more as a validation tool, but I think they use drainage as a validation tool. So we want it to be at least a first pass design tool. But understanding that a solid review of your calculations is going to be required. Some quick highlights of the process. ORD drainage has scenarios. So in geopack drainage, I'll leave it again. Geopack drainage, you basically went in your preferences. You told it that you wanted to run 4 inches per hour. And then you told it that you wanted a tenure for pipe calculations. You don't do that now. Now you have scenarios. So we have 2 scenarios that you're always going to run. One will be the 4 inch per hour for spread and bypass. You'll place nodes in drainage areas, or catchments as they call them. The scenario won't be used to design pipes. It will, but it won't. It's not going to count on ours. And it can be run before you place any pipes. The second scenario will be for the 10-year pipe design. The scenario will design the systems for a first pass. And if you want or need to set controls on pipes or tops and inverts, you'll make those adjustments in this scenario. If you need to run analysis for a different design year, you'll run a third scenario. So if you have a sag and a curb and gutter, if you have a catch basin and a sag with no relief, you would run your design year storm in a third scenario. So I've got a couple of red flags to point out. The first one is in geopack drainage, if you change something in the drainage library, it would be overwritten the next time you updated your workspaces. Now everything is stored in a feature definition library that is written to your DRN file when you place the first drainage node. So if you change an IDF curve or characteristic of a catch basin or anything else, if you add a node, whatever you do in your drainage file, it's made to that file. Updating your workspaces won't fix it, change it back, but it also won't change the next file you place. The feature definition library is the backbone of the ORD drainage. I think it's probably the backbone of most of ORD, but it's particularly affects us, I think. I know there's going to be a lot of things we've missed. If you find them, please let us know. I'm going to say that like 6 or 7 times today. We'll try to keep everyone up to date on what needs to be fixed in the file they're working on. We believe that if there's a new type of pipe or node that needs to be updated, added, we think that can be synced to a feature definition file or synced to your drainage file. But if it's an existing one, the change has to be made to, it's going to have to be made manually. Are you confused? I am. So what are some of the problems? Well, some of the biggest one is the NCDOT VBAs from V8 are gone. So we had VBAs that helped label plans like structure number, type, other things like tops and inverts. We had a VBA that created storm drain and inlet comp sheets. We had one that created drainage summary systems or drainage summary sheet. And we had one that ad hoc data to elements that were not placed by geopack drainage, like flowable fill, pipe removal, and driveway pipes. So we have to figure out the best way to replace these VBAs as simply as possible. Because as a user, I don't want to approach this as a user. We're not trying to drive people crazy by how much work there is involved in this stuff. So, but also there's not an easy button on this stuff. So we'll see where it goes. Geopack drainage used minimum cover at inlets to create a minimum depth design and standard box depths. The current release does not offer that option, but we hope Bentley will be coming out with that option soon. We've certainly talked to them about it several times. Because of this, I believe you will need to be more hands-on with your top and inverts and pipe design during the initial stage of ORD drainage. When the minimum depth option is included, it is our hope and our belief that the standard depth boxes will be more automated. But you're still going to need to check your calculations just like you do right now in geopack drainage. So plotting, we have not tackled plotting yet. We've been fighting enough with the workspaces that we haven't been able to do that. At least internally, we used to copy roadways plan sheets. Now they say we can't do that. They say it's easy. We'll see. We need to make sure we can still plot our red lines. We need to be able to plot BSRs and CSRs, which short term, we're still planning on being in 2D. I know there's a hope to go to change those at some time, but we'll see where that goes. And we need to be able to plot permit sheets, including blow-ups and cross-sections. So another red flag that shows up here is if roadway makes changes to their DSN file, if they shift an alignment, if they add a turn lane or something like that, the boxes are going to shift with them. When you open that file, it's going to shift because it's tied to that. Whereas in geopack drainage, it pretty much stayed where you'd placed it and you could tell where things had changed. So we're going to need good communication with roadway from here on out, or as good or better than we've had. There's been a lot of discussions on converting their files. When are we going to move from geopack to ORD? After talking with Bentley, we have a lot of work to do here. Not just us, but Bentley does. There's not an easy button to go from 2D geopack to 3D ORD. I haven't watched the 45-minute video that I'm going to have to watch on that. Everything, and another thing is everything that we placed by hand that was ad hoc with VBAs would have to be redone in ORD because it may transfer the stuff that's in the GDF file, but it's not going to transfer the flowable fill, the pipe removal, driveway pipes, elbows, stuff like that we just had people place by hand. So stay tuned on that and let me know if you have thoughts and suggestions. My wish is that we would not convert to ORD if we've already started in drainage. But if we've already started on the drainage, but it's not just us that affects this stuff. So we'll have to see where it goes. What changes are we seeing? Well, we've lost the toolbar, the hydraulic toolbar that we've had for the past 8 to 10 years. It's still kind of there, but you can't make sense of it. So we created we've recreated the toolbars in the element templates. So now it will take 2 steps instead of 1 to place something, but it will work. And an example of this is if you wanted to place a typical, you would go find that typical ditch in the element template. You'd click it, and then you go to place cell, click it, and then you place your cell where you need to go. Once we get everything else fixed, maybe fixing that toolbar can be something that we can go get to, but it just can't be a priority right now. So levels. So we used to have a level for every pipe size and type, and we had a level for every type of label. So without the VBAs to move the pipe to the correct level, we are planning on having more generic pipe levels like class 3, class 4, and CS pipe. So because we feel like most of you know when you're placing that pipe that you know what type of pipe it's going to be. So the properties will know that it's an 18-inch pipe, which will help with the labeling once we get it figured out. And we've got to figure some labeling stuff out too. So hopefully that made a little bit of sense. So 3D models. Everybody loves a 3D model, and we're building towards that. But for us, the question is, how accurate does the model need to be? We're trying to minimize the choice that the user has to make when you place a node. No matter what, you'll have to go through the system at least twice to make sure you have the right box sizes. For example, with catch basins, there is a less than 48-inch and a greater than 48-inch pipe option for each grate type. A less than 48-inch box has a box dimension of 4 foot by 4 foot, and a greater than 54-inch has a box dimension of 6 foot by 6 foot. The model is, that makes the model not that accurate, but is it good enough? Because, and we've done similar things for the other node types, for 2GIs, manholes, and stuff like that. Because if we accounted for everything, then we would have hundreds of feature definitions and probably more than 1,000 cells. I mean, you would have to have a box where you had a 15-inch, two 15-inch pipes coming in. If you now changed it to a 15-inch and an 18-inch, that would have to be a different one that you would select, and so on and so forth. And I just don't think anybody wants to do that. And you would have to touch it every time you made a revision. So we hope that parametric cells are going to come into being. They've been talked about for years. The parametric cell would basically resize themselves according to the pipe sizes coming in. Bentley keeps talking about this, and we'll see what happens when it does come in. One of my worst case scenarios for how accurate does a model need to be is a 2GI in a shoulder berm gutter with 2 elbows and an outlet. If you do that, you've got 4 nodes and 3 links, or conduits now they're called, I'm sorry. Where do you put, how accurate does it need to be where the elbows are? These are things that we never worried about in a 2D world. So we got to worry about them now. So positives, ditches are a positive, I think. Cross sections have changed. We've lost the XSC file, I think. That's what roadway's kind of telling us. There's going to be an XPL file. The one time we had lost all the cross-section navigator tools, but they said those are coming back in 1010. But I think that we're going to be able to automate using templates the lateral ditches and possibly some of the special cut ditch stuff. We're working on a manual and a process for that also that we'll post. We'll see how that goes. There again, here's the last big red flag that if roadway changes things where the slope stakes move, those ditches are going to move, but they're going to be tied to my understanding is they'll be tied to the profile, so your depths could change and you'd have to go back and look at those. We're going to need that communication. The hydraulic design engine is very strong. It can do more in-depth analysis than geopack drainage can, but we got to learn how to use it. Bentley seems to be sincere in their desire to make drainage better. We should see improvements to minimum time of concentration, spread, and minimum cover in upcoming releases. They're kind of saying fall, but we'll see what happens. Hopefully so. I know y'all are going to ask what kind of training we're going to do. We're mainly going to do in-house training, I imagine, but we will have the manuals and learning paths on the webpage for private engineering firms. We need your suggestions and your comments, and we need your help. It is going to be crucial that y'all tell us what's wrong in the workspaces. It's also going to be important that y'all tell us when y'all find a good workaround or something that would make things better. If we all share, then what one person learns was going to help another and vice versa. So I'm the contact person for the near future, and that'll be how we're going to proceed. My email address is on the web. It's on the screen. So we'll talk more after everybody else is getting their presentation. I appreciate your time.
Thank you, Bill. And Ernie, nice job on the slides for sure. Really appreciate it.
All right, well, we'll head over to Jeremy Goodwin with Roadside Design Unit, giving a presentation on erosion control.
Yep. Let's see here. Oh, not this one. Hold on. Getting the right presentation here. Hold on. Make sure I share my right screen here. Bear with me. Let's see. There it is. All right, I believe everybody can see the slides now.
Yes.
Excellent. Well, let's see here. All right, Jeremy, I'll tee you up to get started here. Jeremy, you ready to take it away?
Yeah, it's still requesting. Waiting for approval.
And actually, like I said, I've got it up on the screen if you just want to talk to it, Jeremy.
Yes, I'll. So my name is Jeremy Goodwin. I am the state roadside erosion control and roadside management engineer.
Hey man, I don't know if I can tear away from this riveting.
So I'm going to discuss the erosion control workspace and ORD and what we have. First thing, this is going to kind of sum up where we're at right now. There's really nothing new under the sun, and that's going to apply for erosion control at this point. If you were to look at the workspace, look at the old SS2, SS4 sheets, cells and stuff. They're going to look a lot like what we're looking at in ORD. Go ahead, next one. Everything's in there. We have a lot of the same items are the same. The cells, the custom line styles, the annotation. It's all built into the templates at this point, and that's what we're working off of. Go ahead. So where are we at with this? Basically, we have been doing plans with the element templates and using the filters to produce basic 2D plans again. That's the same stuff that we were doing in the past. However, you're going to see a lot of the exact same items, a lot of the same issues, and it's also going to lead into the fact that we're still having to use the spreadsheets a lot. Sorry. That's unfortunately where we're at. You're having to still delineate drainage areas on the plans, and then, sorry, of all things. And you're still going to have to keep using the spreadsheets for calculations, because as anybody who does roadside workforce knows, roadside loves their spreadsheets. And there's a lot going on with those, but they are going to be used for the foreseeable future. So question is where we're going. We're trying to get all the functionality we had back with the GeoPack, with the design and computation manager, and hopefully exceed that. We were kind of sticking with the templates and kind of stalled there and realized that that's not where we need to be. We need to be moving on to using feature definitions like all the rest of the groups, which is where we're at now. We hope to have that finished up in the near future. The items are basically being split up between linear and point features for all the cells. Annotation still in there, just because of the way we do annotation for multiple plan sets off the same file, the final phase or clearing grubbing. We're still looking at sheeting. As Bill kind of mentioned, we kind of piggyback off the roadway as well, and that's not really going to be the preferred method. So we were looking at how we're going to do that in the future. And of course, we're going to have to update the pin tables with that methodology and some of the changes we're making with the levels and the naming conventions. One of the other things that this brought to us was that, quantity calculation was an issue, and with the feature definitions, we can incorporate item types, and we can go into the asset manager. This is the next one. and use the asset manager for our quantity calculations. I'm certain everybody would like to go back to the early 2000s of hand counting quantities for several days and putting them in spreadsheets for maintenance factors and manipulation. But I think this is the method we're going to be using in the future. We have kind of done some rough tests on it, and it seems to give us the functionality we need to do the calculation. It also gives us some flexibility on what we're counting and how it's counting, so that we might be able to simplify some of those estimate spreadsheets. But like, this is still in the early stages as well. The other thing we're also working on is, as Bill alluded, is the 3D workspace and modeling. We've done some very basic stuff. I've got one of the staff that's working on it. He spent some time just basically doing linear items. The big one, however, is going to be modeling the basins. I mean, that's where most of our issues arise from, the conflicts between that, the fact that we usually have to estimate the outside toe of the basin with the contours, and then it not matching up as well as it should have in construction, and us needing additional room to either install it or to maintain it. So that's one thing we're going to focus on in the near future once we get some of these other issues tackled. Like I said, right now we're looking at it from a linear template standpoint. That seemed to be the easiest method, but for everything we've experienced, it's very time consuming. And with the number of basins that we're going to put on plans, modeling each one as a pond may not be functional in order to keep schedules going and keep work going. With that, like I said, there is definitely a lot of potential with ORD, and we're looking into that. With the drainage analysis tools, we're basically waiting on Hydro to see how they're going to handle it, to see what we could possibly use, so we're not replicating a lot of work. The prospects of having those contour basins definitely something we're definitely looking into. Hopefully we can get some calculation of temporary ditch liners with linear templates, and possibly even getting the slope mattings calculated, with the meshes. And there's also the hopeful attempt of automating summary tables. Anybody that does EC work, I know they love sitting there manually entering all of the data from the spreadsheets into a plan sheet summary table. But as Bill said, let me reemphasize this: we're going to need help. ORD was not really designed to do erosion control work, so a lot of the stuff that we're doing, we're kind of pulling from different groups in different areas, looking at different tools, and there are tools that we don't know about that may be a better functional item to use, and there may be some hiccups we still have that need to be corrected. So as y'all begin working with this, please, feel free to reach out to myself or Jeff Walston, and we can try to get those comments and try to see if we can't get a better product out for everybody to use. So in summary, looking back at it, is there nothing new here? Well, at least not yet. We are looking at some changes in the future, and I think with y'all's help, we can probably get a better design product out there for everyone to use. And like Bill said, I would like to thank the folks who work on this roadside. That being Jeff Walston, Alex Getty, Noel Ring, and Wes Chandler. They put a lot of effort into this, and there's not a lot of time to do it, but they have done a lot of work going above and beyond what they have to work with. Anyway, that's all I've got.
Thanks, Jeremy.
Thank you.
All right, next up, we've got John Lowry. He's going to be presenting from the utilities side of the house. So with that, I'll let you start, John.
Okay, thank you everybody for joining us today. First thing I wanted to start out and say thanks to Jeff and Vaseem And one of our big helpers here has been Robert Garrett with Vaughn and Melton. He has been a vital part. He was contracted to help us out rather late in the game due to funding and budget stuff. As we all know, that kind of put a kink in some of the plans. But I also want to go on to thank Oak and Jason and Roadway, and there's a bunch of other ones. I'd have to make a big list, but Oak has been a vital part of this as well, helping us and Jason and that team over there. But just to start out, really wanted to thank them because they've been a big part of this. But for those of you who don't know me, my name is John Lowry. I am a senior utility engineer in the utilities unit in the central office. My section is the central region. We're divided up into three different. We have the east, central, and the western. Basically, I've worked in roadway design and utilities for the last 26 years. Most currently, I think it's approximately 3 years in the utility unit. And basically, with all the budget cuts, everything that's changed over the last several years for everybody, a lot of our work has been outsourced. And with that, our experience and knowledge in CAD has been depleted. A lot of people that have been hired on for engineering, they're just reviewing plans from consultants that come in on a PDF and they verify some stuff, but they don't have a lot of design experience. So we're faced with trying to establish a level of service and incorporate a training program to get everybody in our unit as well as all the consultants and everybody we deal with. Next slide, please. Jeff, are you flipping?
I am. Is everyone able to see the title utilities unit and providers?
That's what I'm seeing now. Oh, no, I'm not seeing that one. So I'll go through on my screen here. Let me change the computer so I can see it, and I'll just let you know, because for some reason it's not updating on mine.
You might have the frozen screen, John, like I had that yesterday.
Yep, I got my other machine up so I can just follow along, and I'll just say what screen we're on so we can work
Sounds
it that way. And I thank everybody for bearing with us on this. Basically, this is something I always ask people whenever I first see them on a project or being involved in a large project is, utility is a little bit different. We have a bunch of different utility groups, and all those utility owners they own their product, and they're required as part of DOT to put forth a set of plans that we can use to design to incorporate their designs into our designs and to move forward with the project. So it's not like we in-house decide where everything is going. It's up to the utility owner, and the utility owner can hire some different contractors to do that, as well as the construction and in design. So I asked people, how many utility companies are there in North Carolina? A lot of people say anywhere from, I've heard numbers of 10, 20, 500. So think about this for a minute. Every time you drive down the road and you see some poles and you're wondering how complicated stuff can be. Slide 2, Jeff. Right now, there's 3,400 utilities regulated by the commission in the state of North Carolina. And if you look at that number there, that's 11 billion, approximately 11 billion in revenues every year. And those are electric, telecommunication, wastewater, natural gas, and others. Others might be stuff like steam. We're still inquiring steam inside project limits and having to deal with rerouting steam lines or removing abandoned steam lines in the project. Next slide, please. Currently, we've been using the Bentley Water Sewer Program. As utilities have said, or as drainage has said, utilities is in the same boat. We're using a program that's been around forever. The oldest I know is 15 years, people that have been using it in our unit. It's not been supported for the better part of that. With the Bentley Water Sewer Program that we were using, there was a need for about 2,900 levels. And that's a lot of levels to manage and manipulate. Basically, that program worked for us at the time, but it was rather outdated and we had to find several different workarounds. There was limited applications for the utility design. There was very little flexibility and excessive amounts of manual labeling, and it was not compatible, and we were never able to make it work with 3D models. Next slide, please. The ORD workspace going forward, what we're able to do is eliminate 95%, basically a 95% reduction in our levels. We're going from 2,900 down to 126. That's a big difference. It's going to help simplify a lot of our utility design. We're updating and revising the utilities workspace. It has just been currently uploaded, and we're adding new standards. We're developing new feature definitions, libraries. We hope to be able to model in 3D for the existing, proposed, and horizontal and vertical. The existing would be all the stuff that is in and above ground. The proposed, of course, is proposed utilities that we're putting in above ground and below ground. The horizontal and vertical aspect of it is we hope to be able to model subterranean, underground utilities in all aspects that would allow us to use clash detection. That is somewhere down the road because we are not even close to that. But we hope that in the process of this, it will eventually make the users down the road a lot easier to do their job with having the aid of clash detection and other stuff that would be used. We're reducing the number of line styles by going to ORD. We've went through, just like all the other units, we went through a new naming for the patterns and levels and templates and feature definitions. And we're having to create the libraries for the utilities, annotations, and everything. So I want to take a side on this other side of the slide here. What you're seeing is how it basically was working and how it will work. In SS2, we would have, because of the way utilities are laid out, we have all these different utility owners. We can have multiple different utility owners, wet and dry. It's possible to have 10, upwards of 20 dry utilities. Then we'll have multiple wet utilities on a project. Some of the large projects might have 3 or 4 different entities, from a county water system to a city and municipal water system. And in some cases, you'll have, in one of my current projects I'm working on, there's a prison that has its own water system, its sewer system, and it has steam lines. And that situation is in the process of realigning to allow the county to take over that facility. And one of the problems with that is they are not only providing water sewer service currently to the prison and keep all the business functions going there. The communities around there receive their water from that water treatment facility and that processing plant. So this entity, which is the part of the public safety, is supplying water to the civilian market, plus they're supplying their water and doing their sewage, and they also have steam lines. And all of those lines are crossing the state right of way in projects. So we have to deal with everything specifically. So when you get into a situation like this, what you see there in that little funnel is we can have state cost, we can have municipality number 1 cost, we can have betterment. And the betterment is determined when they want to upgrade a line. If they had a 12-inch line and they wanted to go to a 24, it's a betterment. So when we're doing all these levels, what we had before is we had different levels, and there could be up to 5 for one type of pipe. A 12-inch water line could have municipality number 1, municipality number 2. It could have betterment 1, betterment 2, and it can have the state cost. And we would break everything out when we try to do our agreement plan, so we know who's paying for what and how it will be done. And by doing the ORD, we went from all those different levels to 1 pipe and 1 level. we'll be able to use feature definitions and annotations in order to establish who owns that line, who is responsible for paying for that line, what type of line it is, and any particulars that go along with it for installation or construction. Next slide, please. As you see, utilities can be really complicated, and I invite everybody the next time they're out there, rather than being upset, stuck at a red light in traffic, is to look around and see what you can see at an intersection. Because what you're seeing here is basically a model that depicts water, gas, sewer, you got drainage, power, overhead lights, and these projects that we get now, especially with restricted right-of-way where we're widening or making road improvements, and the right-of-way is very tight, and it's very difficult to get additional right-of-way and additional easements, permanent drainage, permanent utility. All those easements are hard to come by anymore on some of these projects that go down through cities or expansions in some of the bypasses and connectors. And what you see above ground is only a small fraction of what actually is going on below ground. And we hope to be able to model everything so that we can determine where our design will fit in conjunction to the design that's already been done by drainage. And eventually when we get there, we'll have the modeling that will help us in various ways, and it'll help us in design and recommendations in the scoping process, so that we know where potential problems will be and how we can address them. But that's going to be a little bit down the road, because our biggest problem is we could model the proposed that we plan to put in. We can model some of the proposed that the dry utilities and most all the proposed for the wet utilities. The problem lies in there is getting the model for the existing. You know as well as I do that when we put stuff underground, it's not a straight line. You know, most of the gas lines now, most of the water lines, they can all be available. Even sewer force mains can all be available where they're flexible. So they might go around an object that's there. They might follow the existing right of way. And on stuff that's been in the ground for 15, 20, 30 years, there's no way of telling whether it was a straight line from point A to point B, whether it's an old line, a new line. And the situation we're going to run into is we do not have all the time like a drainage system would have, where you have an invert in and an invert out, with the exception of sewage. So our water lines, we can look at valves, we can look at joints, we can look at anything that we have a manhole or a service hole, a hand hole for dry utilities, but it is very difficult to see what's going on without doing a lot of test holes or without having some advanced way to survey and find all these elevations and what the depths are to find out if they'll be in conflict. Next slide, please, Jeff. What we're doing right now, what we're planning to do is have the option, and what you see on the left side of the screen is the utility in a 2D environment, and you see on the right the 3D environment. The 2D, we hope to be able to draft and put everything in and have it transfer over to the 3D. And we're going to use the 3D down the road, but the 2D environment is where pretty much where we're going to go forward with it and how our designs are going to be done. Eventually we'll be able to do the 3D. The problem we're running into with the migration to ORD, as well as other situations, all of these utility owners are responsible for providing the utility by other plans. So what they do is they incorporate a design and then they submit it to our consultant or our unit itself that has a utilities coordinator. That utility coordinator currently is responsible for taking all their designs and incorporating them into a design that we can use for the wet and use to check for clash and conflicts on the dry side of it. as well as so we kind of merge them all together, and we overlap them with the roadway, of course. So we know where drainage is, we know where any ditches, berms, walls, and we have to use all this stuff that was already done. And our work can come as a early on for design and kind of speculating what we can and can't do and what we need to avoid. But there's really no work that we can provide until we have full roadway and drainage plans. And at that point, we're allowed to go forward and do a hard design, because we know where all that drainage, we know where all these conflicts are. We can look at each one individually and say, you know, there might be a situation where we can move a drainage pipe and avoid a conflict on a gas line for the entire project. And it might be one pipe, or it may be multiples that we end up having to relocate the gas line. But eventually keeping in this 2D aspect, because these utility owners are responsible for their own design. And I'm talking about Duke, Windstream, the old Time Warner, anybody that operates towers, anybody that has any kind of power, anything in the ground that's inside of our right of way. These people submit us a plan, we incorporate it into one plan, then we merge it and determine where the problems are and what adjustments need to be made. Those folks are not required as a property or a utility owner to really use ORD to incorporate their plans and send to us. So we're going to have our consultant that's doing the utility coordination to incorporate that into their design. And so currently we're using a 2D, and our final turn-ins are submitted in a PDF. So the 2D will have to hold strong for a while when we figure out a way to convince everybody to shift over to modern technology instead of crayon drawings. And you know, you got a utility owner that has one or two poles that are affected, and that might be it on a big project. And they're not wanting to spend the time to do anything more than download a PDF of the current design, draw a sketch of where they're putting or moving their lines, and then they submit it to us. On the wet side, the basic water sewer is owned by the county, the city, and all the municipalities will deal with that. They can hire who they want. They can ask us to appoint somebody to do the work. Generally, they usually know up front who they want to do the work for them. And then we deal with them to incorporate a set of plans through a consultant that they've hired to do the design, and then that consultant sends that design to us. We're currently in the process of working with our consultants to try to get them up to date on ORD, so that at least all the proposed wet design can eventually be submitted in 3D. Next slide, please. What you're seeing here is basically how it goes from 2D to 3D. Basically what's in each bracket would be the levels and the cells, the element templates, the feature symbology, and feature definitions. When you look at a 2D design of a gas and a water line, in this case, you have the valve and you have the fire hydrant. It looks pretty simple until you look at it in the 3D aspect, that gas line might be snaking below one section of the water line. It might have to go over another section of the water line and weave in and out. And so where the 3D aspect will come in is it'll allow us a lot more ability to determine and prevent conflicts and make sure that we maintain the standards and rules that are set forth on water, gas, sewer, and everything to protect those lines and to protect the general public. Next slide, please. What you're seeing here basically is that same thing where it's just pulling off a cell, and the 2D going to the 3D will be able to depict the size, just like drainage. We're going to be able to depict the size of the boxes, the manholes, all that stuff will be able to be put in an actual size that will help us detect whether there is a conflict or not. Because as we talked with drainage early on, and we were talking about the size of the pipes, the type of the pipes, the type of the boxes, it gets very difficult if we don't know an exact type of a box, whether we have a conflict or not for a drainage box. And we can work off the worst case scenario, but the last thing that state wants to do is buy additional right of way because we kind of went off speculating that, hey, let's throw this size box in here and we're buying additional right of way to maintain, or additional permanent utility easement to maintain a water or sewer line. We want to be as responsible as we can with the state's money and not have excess. In the ideal world, I would say we need a channel 50-foot wide on the outside of each project, and we'll do all our utilities there and let the roadway crew do theirs. But it'd be wasteful spending, and it'd be a lot of extra right-of-way cost and expenses. But you do see that in some cases where the municipalities will buy their own dedicated right-of-way. So they're buying areas for utility easements, and you'll see big power lines. You'll see a lot of sewage systems. And they found it better to rather parallel or piggyback on a road or a project that we got, is to reroute their own stuff, do it so that they will be down the road not having to change or correct that. And by doing the model from 2D to 3D like this, we hope to be able to keep the footprint of the project as tight as we can, but yet still have something that's very effective and works out well for us. And next slide, please. And what you're seeing here is what the 2D will provide for us. The 2D is going to give us our general design. And you're seeing on the left side, you're seeing a gas line and you're seeing a water line. Well, in this situation, eventually when we get checking for conflicts, right now, everything we do is by hand, basically crunching numbers, figuring out what that drainage pipe is, figuring out where the low spot is on that. And the issue can be is a lot of people guesstimate going off of inverts. And if you know anything about inverts and where they're measured, drainage pipes and sewage and water systems, valves and all that are always bigger than what the pipe is and where the invert is. You have a bell on a pipe that may add an additional 6 inches to 10, 15 inches for a flange or anything to the overall diameter. And you have to know exactly where the high spot is on the line that you're trying to miss, and what minimum coverage you need on your line you're putting in, so that you can keep vertical clearance and not have a conflict with it. Eventually, when we go to 3D, we will have clash detection and conflict analysis and everything. And what you're seeing on the right side is it showing that this water line is not going to work, because there is no way, form, or fashion we're going to stick a water line through a gas line or vice versa. So it will let us know up front that we need to work on something and change the design. And possibly in this case, it may cause an additional right-of-way. And if we catch it early enough, we're not going back for a revision because we need to move something. We're not going back for an extra claim, a Z claim. We know up front what it's going to take. We know exactly where the stuff is. But like I said, that's down the road. That's the clash detection and conflict analysis part of it. And all this is wrapped into the drainage and utility aspect of ORD. Next slide, please. Here's a really good picture of what it's going to do when we end up with 3D modeling and we can determine where everything is and what's going on. We can establish, it is my understanding, we can set a minimum and establish a clearance that we want for different lines. When we run that, we will know exactly where it's too close and how we can adjust it. And by doing so, if we have a minimum clearance we need to make, or if we're hitting the pipe directly on, we can determine where we need to adjust it, if it's possible to adjust it on top or below. In this case, you're looking at a sewer system, and it's just kind of a bland color, but yellow is generally always gas. You have the sewer system that shows up green, but in this case, it's just a generic color, and it looks like probably a water line. So you have that manhole there. The manhole is going to control, and the gas line obviously you can parallel it, but you got those cross pipes. You got to miss the cross pipes. So this clash detection and conflict analysis and everything will help us dramatically. And instead of waiting until the division's out there, trying to figure out how we're going to fix a problem because they're digging holes because they found something in the ground that wasn't supposed to be there. Hopefully we catch that with the conflict and clash detection. Next slide, please. So where we're currently at in the ORD implementation. We're working, we will continue to work with ORD, and the files will be in 3D, but we will be creating a 2D product. The flexibility, you know, we need to be able to be flexible to work in ProjectWise. ProjectWise is going to be a real catch for us in a way. ProjectWise, in order to get everybody access, you got to remember the number of utility owners we have. Not all of them have a system that can get into ProjectWise. So currently what we do is how we're going to have to move forward for a while, where we provide download files or print files or even send them stuff that they can print in a PDF format because they can't handle the ORD. They can't handle that. And so they're not going to be able to go on ProjectWise, pull stuff off and work from ProjectWise like normal roadway drainage and standard utility engineers will. And on the other side of it, we have a bunch of different consultants that do all these utility aspects for the municipalities. Those municipalities hire a firm, and that firm may be doing it in AutoCAD, and what their standard is to do it in AutoCAD, then they convert it over to MicroStation before they submit it, so that we do have a plan design that we can check, and we have PDFs for the turn-in. We're trying to get all them to shift over to where they can convert and do the 3D models. We understand there's a process for it, but we have not investigated it too far, and we have not had the time to experience trying to convert some of those files over. So there's going to be a lot of ongoing software testing. There's going to be a bunch of new configurations, updates, and releases, especially with the 10.10. For our labeling, we hope that annotations and everything will handle that. We have an extraordinary amount of labeling and boxes on the plans. We hope that a lot of this will be taken care of through that. But in the meanwhile, we're trying to figure out workarounds for labeling and everything to use the current issue of ORD. Next slide, please. And at that, I will end it. I want to say that, again, my name is John Lowry. I'm in the utilities unit. Very easy to find me. And right now, this is I don't want to say a hobby, but it is a side job from my normal job. I'm normally every day just working projects, and was picked to do ORD because I had picked to work with the ORD group because I had a background in roadway, and I had probably the most experience over there in CAD. With a little bit less, there's some other guys that are more qualified maybe in the utility aspect because they've been using some of this software over in utilities for 15 years. So it's a team of us over there. We all approach everything as a team. We want to work together. So I would be the lead contact. If you have questions, concerns, want to talk about anything, feel free at any point in time to discuss them with me. Send me an email, shoot me a message on Teams, and we'll be returning back in the office. Some of us will be working part-time from home, part-time in the office. We'll be returning back in the office soon, and we'll be available for face-to-face meetings, sit-downs, and demonstrations on the CAD stuff. So we're here. As I said, with the rest of my team that have been helping with this, we're all going to be available. And I really appreciate everybody's hard work. Bill has done a lot for the hydraulic section, and a lot of that stuff with the drainage and utility is going to transfer over to us that he is doing. So it's very similar. It's the same program, and we will move forward and try to help you any way we can. And at that, I'll turn it back to Jeff, and he can open it up for questions for the general group.
Thanks, John. Thanks, everyone.
Yeah, Jeff, do you have anything else to add?
Okay. Couldn't say another possible thing that hasn't been covered. These guys did a fantastic job, Ian.
Yep, that's great. All right, we are coming up to 10 o'clock. We're past 10 o'clock at this point. So be respectful of everybody's time. But feel free to, you can send into this chat. It'll still be functioning after the presentation. Also, Vaseem added the email address to send in information or tips or questions to NCDOT to get input from them. So just a reminder, our next NCDOT presentation for this this week is going to be at 12 o'clock today, with locations and surveys being the topic. So I'll respect everybody's time and go ahead and close it down. But like I said, feel free to reach out to NCDOT and get those conversations going if you have any questions. So appreciate everybody's time, and you guys have a great day.
Thanks, everyone.